Hello and welcome. In this video, we're going to cover an exercise where we take the status of an output, red light, and we use the status of the red light output as an input to turn on our motor when the red light is off. So this is a simple exercise where we take an output coil, an OTE, and we use the same address that we use for the red light output coil to turn on or off our red light contact. The common mistake that I see with this type of exercise is students will use a different address for the input contact for the next branch, and that's incorrect. And I'll show you why in this video. So the first thing we want to do is we're using the AWS app stream shown on the right hand side, and we are going to use the emulator with the RsLogix 1100 PLC. So first we want to open RsLinx Classic, and we want to add our emulator driver. So this is the SLC 500 DH45 emulator driver. We'll click on add new, and it doesn't really matter what we name this, it's going to delete it anyway. And then I just give it a station address of a number that's going to be different than my processor. So you can see that my emulator driver is added and it's running. So we'll go ahead and minimize RsLinx. We also want to make sure that RsLogix Emulate 500 is open. This will allow us to emulate the program. And we'll minimize that, and then we're going to create a new project with a RsLogix 1100 Series B PLC. We'll choose the emulator 500 driver, and we're going to choose a processor node that is different than the one that we chose for our driver. So 1 is fine since our driver is address 4. Okay, once we have RsLogix 500 open, we want to do the I/O configuration. So we need to add a few cards here. So to mimic the stations that are in the physical class, we will use the IQ16 card on slot 1, and then we will use an OB16 card on slot 2. Those are really the only two cards we need for this exercise. So we'll click OK, exit out of that. And then we're going to start building our logic based on the diagram on the left-hand side. So first we're going to add our red push button, which is a normally closed contact. Or in Rockwell, it's a examine if open. So for this one, we'll give it the first address on our slot 1 card, and we'll just call this red push button, and then we'll call this red PB. Next, we'll add switch 1, and this is going to be input 1-1. We'll call this switch 1, and then for the symbol, we'll just do SW_1. After that, we'll add switch 2. This is going to be input 1-2. Call this switch 2, and the symbol will be SW_2. Next, we need an output to energize coil for our red light. So that will be our first output, which is going to be output slot 2/0. This we'll call red light, and then here we'll just call it red LED. Now we need a branch between switch 1 and switch 2 that wraps around our red light. So to add a branch, we'll pull that from our instruction list. We'll wrap it around our OTE coil. And below our switch 2 and red LED coil combination, we're going to add a normally closed contact, which will be the same address as the output coil. And the reason for that is we are monitoring the status of this output directly. So we just simply use the same address, and that will function as a status input to then energize or de-energize our motor depending on the state of our red light. So the common mistake I see here is instead of using the same address, the students will use the next available input, and we'll show how that wouldn't work once we run our program. So next we're going to add our motor, which is going to be the next available output, which is output slot 2/1. We'll just call this motor MTR. All right, now we're going to verify our run, make sure we have no errors, and I'm going to go online with the download. And then we want to put our program in run mode so that we can test it. And so now if I toggle switch 1, you'll see that my motor 1 is on because the red light is off. However, if I switch the red light on, you see that there's no change in my motor, and that's not what we expect. We expect there to be a change to the motor's output depending on the output of the red light. So I'll go ahead and go offline to fix this. And the way that we're going to fix it is by changing our reference address for our red light to match the output address for the same red light. So that will be output to 0. Now we'll verify the rung. And next we will download and then place our program in run mode. Now you can see that with switch 1 and switch 2 on, my red LED is on. Now if I switch 2 off, then my red LED is off, which then energizes motor 1. I can show the same thing with turning off switch 1. That will turn off the red LED, and now neither are on because I don't have continuity through my rung. So I only have continuity up to switch 1, and because switch 1 is false, nothing after that is going to be energized. And then lastly, if we toggle our push button, this will de-energize everything downstream regardless of the state of switch 1, switch 2, or the red LED. All right, thank you for watching, and I hope this helps.